Hello everyone. The first question here says the author of the passage mentions calculations about tunneling time and barrier thickness in order to. This last part, in order to, is very important. We call these questions specific purpose. Specific purpose. And to attack a specific purpose question, first, you need to find the keywords from the question and then look for those keywords in the passage. Okay, so let's focus first on identifying the keywords. It says calculations about tunneling time and barrier thickness. You read and you scan the passage, you look for the keywords right here. The grounds were calculations that suggested that the time it takes a particle to tunnel through a barrier increases with the thickness of the barrier until blah blah blah. So you really need to understand that sentence. So, okay, great, we found the keywords, we found the essential sentence that contains the keywords. But pay attention to the end of the question. It says, in order to. So what is the purpose of that particular sentence? Why did the author write it down? Okay, and you will find out that the purpose will always be either to weaken or support something. Okay, it's one or the other. You either weaken or support. Now, since the sentence begins with their grounds were calculations, the word grounds means supporting evidence. Okay? So the purpose of those calculations is to support something. What should you do? Well, connect that sentence with the sentence before. Most of the time that works. So notice that the sentence before says, though the extreme rapidity of quantum tunneling was noted as early as 1932, not until 1955 was it hypothesized. So you have a hypothesis. What is the hypothesis? That tunneling particles sometimes travel faster than light. So that's the hypothesis. Now, what premise or what evidence supports the hypothesis? Well, you have it right after. It says their grounds were calculations. So what is the role or function or the purpose of those calculations? Well, very easy, to support the hypothesis. So once you find the keywords and you understand the purpose of those keywords, which in this case is to support the hypothesis, that's your prediction. Okay, so the answer has to tell you exactly that. Which answer tells me that you're supporting the hypothesis? So look at the options. Number one says, suggest that tunneling time is unrelated to barrier thickness. No. Explain the evidence by which Winger discovered. Be careful, they did not discover the phenomenon of tunneling, okay? They have a hypothesis. Describe the recently challenged. No. Question why particles rarely achieve. No. Explain the basis. Yep. There you go. So you found the keywords. Explain the basis or the support. By the way, basis is the premise, the evidence for something. Explain the basis for the hypothesis. That is your answer. How do you know? Well, because their grounds means their support. Their support for what? For the previous sentence, the hypothesis. Okay? So I know this is a technical passage, but you do not need to understand every single word. Okay? You just need to get the main ideas. There is a hypothesis. Even if you don't understand what the hypothesis talks about, don't panic, okay? Just get the keywords. Take a look at the next question. It says, the passage implies, okay? Implies is an inference question. Whenever you see the keywords imply, infer, or suggest, you're usually in front of an inference question. So, the passage implies that if tunneling time reached no maximum in increasing with barrier thickness, then, okay, so again we need to find those keywords. Okay, so let's look for them. If tunneling time reached no maximum. What is that? Okay, I just read something right here. Reaches a maximum. Okay, so let's pay attention to that sentence, the sentence that contains our keywords. And it says, their grounds were calculations that suggested that the time it takes a particle to tunnel through a barrier increases with the thickness of the barrier until tunneling time reaches a maximum. Then we have, beyond that maximum, tunneling time stays the same regardless of barrier thickness. And then, the next sentence seems to be important. This would imply that once maximum tunneling time is reached, tunneling speed will increase without limit as barrier thickness increases. That's actually the key sentence. Okay, so the passage implies that if tunneling time reached no maximum, what would happen? Well, what we know is that once maximum tunneling time is reached, so if you reach maximum, what happens? Tunneling speed will increase. So what are we looking for? Well, we're looking for the opposite. It says no maximum. So pay attention to this cause-effect relationship or condition. It says, if you reach max, what happens? Speed will increase. Therefore, no max, then speed does not increase. Be careful, the speed does not decrease, it just doesn't increase. The speed does not increase. Okay, so it's basically the opposite of this. Max speed increases. No max speed does not increase. So that's called a prediction. Now you know what you're looking for. Before reading the answers, you should know what the answer must tell you somehow. Okay, at least get an idea. And let's see, tunneling speed would increase? Nope. The speed would decline? Nope. The speed would vary? Nope. The speed would not be expected to increase. There we go. Our prediction. D matches our prediction. E, successful tunneling would occur even less frequently? No. Okay, so this is a very common condition. Sometimes, well, they're very similar to cause-effect relationships. If A happens, B happens. If A does not happen, B does not happen. Okay, so D is the best choice. Okay, and what about this one? Which of the following statements about the earliest scientific investigators of quantum tunneling can be inferred? Okay, so let's look for keywords again. The earliest scientific investigators. Where is that? Okay, I think I found it. It's right here. It says, though the extreme rapidity of quantum tunneling was noted as early as 1932, not until 1955 was it hypothesized. What? That tunneling particles sometimes travel faster than light. Notice that most of the questions deal with the same part, right? The same sentence. Okay, so what do we know about the earliest scientific investigators? Well, we know that the extreme rapidity of quantum tunneling was noted very early by some people. Okay? But then, until 1955, so more than 20 years later, 23 years later, was it hypothesized something. What does that imply? What can we infer from that information? Well, you can safely infer that before 1955, the early investigators did not hypothesize that tunneling particles travel faster than light. Okay? So you make your prediction. Again, you find the keywords in the question, you find those keywords in the passage, you make your prediction, and then you can look for the answers. So A says, they found it difficult to increase barrier thickness continually. Nope. They anticipated the later results of Chow. It doesn't say that. They did not suppose that tunneling particles could travel fast. By the way, suppose and hypothesis are related. So C could be the answer. They were unable to observe? Nope. They made use of photons? It doesn't say that. Okay, so C has to be the answer. Why? Because they noted the extreme rapidity of quantum tunneling in 1932, but they did not make a hypothesis, they did not make an assumption until 1955, when Wigner and Eisenbud hypothesized that tunneling particles sometimes travel faster than light. Amazing, right? Okay, so good. C is the best choice. So, to sum up, what are the strategies? First, you have to read the whole passage at least once. Okay? Actually, I don't recommend to read the passage more than once. Okay? And when you read it, you have to make connections, right? You have to look for theories or hypotheses or maybe any claim, any opinion. Okay? Now, sometimes the main ideas, as I mentioned at the beginning, are related with surprising new information. Okay? Then you go straight to the questions and you start looking for keywords in the question. You find those keywords in the passage, and once you make your prediction, once you have an idea of what the answer should tell you, then you start looking at the answer choices. And with those steps, you can answer almost every single question in reading comprehension. Okay, so I hope you learned something. I really love physics and biology. Those are my favorite topics. If you dislike them because you think they're challenging, I highly encourage you to start reading more about science. Okay, science is so exciting. I love it, and I'm pretty sure you can learn to love it as well. Okay, I hope to see you soon. If you have any question, email me to teachers@gmatdudes.com. Thanks. Bye.